Hi student, my name is Professor Prakash Vasankar, author Engineering Mathematics first, second and third, Mathematics part first and part second for class 12. Welcome to my YouTube channel. Today we start Mathematics part second for class 12 and exercise 1.1 in unit differentiation. So here we solve here first problem, and first problem is find dy by dx, find dy by dx if y is equals to, if y is equals to in bracket here, and bracket terms are x cube minus 2x minus 1, x cube minus 2x minus 1 to the power, to the power here 5. We find here the derivative of one simple functions, and function is given y is equals to x cube minus 2x minus 1 to the power 5, and we find here the derivative of this function, that is dy by dx. Means here differentiate the given function with respect to x. So first we write here the given function, and given function is y is equals to, given function is y is equals to in bracket x cube minus 2x minus 1 to the power 5. We write these functions here. Then differentiate both sides with respect to x, and we find here dy by dx. So here differentiate both sides with respect to x. Differentiate both sides with respect to x. Therefore, here ddx of y means here dy by dx is equals to ddx of y, that is dy by dx is equals to ddx of RHS, and in right hand side function is in bracket x cube minus 2x minus 1 to the power 5. Therefore, here dy by dx, which is equals to, we find here ddx of x cube minus 2x minus 1 to the power 5. And for finding out the derivative of these functions, we use here the simple derivative formula. We know that ddx of x to the power n, x to the power n minus 1 into derivative of x, or ddx of fx to the power n, which is equals to n fx to the power n minus 1 into f dash of x. Similarly here fx changed to x cube minus 2x minus 1. Fx replaced by x cube minus 2x minus 1. Again, we repeat this. Here we use the formula ddx of fx to the power n fx to the power n minus 1 into f dash of x. Similarly, here 5 and this bracket to the power 5 minus 1. So we write here this bracket to the power 5 minus 1. Into here derivative of x cube minus 2x minus 1. ddx of this bracket, that is x cube minus 2x minus 1. Therefore, here dy by dx, which is equals to this 5 x to the x cube minus 2x minus 1 to the power 5 minus 1, that is 4. So we write this here. Five minus one, that is here 4. So we write here 4. 5 as it is, x cube minus 2x minus 1 to the power 5 minus 1, here write 4. Into in bracket in bracket, here we use addition and subtraction rule. That is when now the ddx of u minus v, du by dx minus dv by dx. Similarly, ddx of x cube, that is 3x square, by using the formula ddx of x to the power n, x to the power n minus 1. Similarly, 3x square, 3x square minus, so right here minus ddx of 2x, and whenever the ddx of nx is equals to n, similarly ddx of 2x is equals to here 2, minus ddx of 1, and here 1 is constant. So whenever the ddx of k equals to 0, where k is constant, similarly ddx of 1, which is equals to here 0. Therefore here dy by dx, which is equals to dy by dx, which is equals to 5 as it is. In bracket here, this 3x square minus 2, 3x square minus 2. So right here 3x square minus 2 into in bracket x cube minus 2x minus 1 to the power 4 as it is. So right here x cube minus 2x minus 1 to the power 4. And this is the required derivative of the given functions. Here we find dy by dx if y is equals to x cube minus 2x minus 1 to the power 5. And derivative of this function is 5 in bracket 3x square minus 2, next bracket x cube minus 2x minus 1 to the power 4 as it is. In this way, by solve here, first problem in board book, that is exercise 1.1. Today we start exercise 1.1 from mathematics part 2nd, and name of the chapter is differentiation. And from this exercise 1.1, we solve here the first problem, that is question number first from exercise 1.1. Dear student, if you like my video, please subscribe my channel and press on bell icon. Next problem, again we solve one problem. Again we find here the derivative, that is here we find dy by dx. So we write here first questions, find dy by dx, which is equals to, we find here dy by dx. If function is given, that is is equals to in bracket and here bracket terms are 2x to the power 3 by 2, 2x to the power 3 by 2, 3 by 2 minus 3x to the power 4 by 3 minus 3x to the power 4 by 3 minus 5 to the power, that is the bracket to the power, bracket to the power here 5 by 2, 5 by 2. Again, we solve one problem. In this problem, we find the derivative of the function y is equals to in bracket 2x to the power 3 by 2 minus 3x to the power 4 by 3 minus 5 to the power 5 by 2. So first we write here again the given function, and given function is, here we write the given function is this, that is y is equals to 2x to the power 3 by 2 minus 3x to the power 4 by 3 minus 5 to the power 5 by 2. And then here differentiate both sides with respect to 2x, because here we find dy by dx. So differentiate both sides with respect to 2, with respect to x. Then here ddx of y, so we write dy by dx, ddx of y, dy by dx is equals to ddx of ddx of this right hand side function. So we write this function here. Therefore here dy by dx is equals to, we find here ddx of 2x to the power 3 by 2 minus 3x to the power 4 by 3 minus 5 to the power 5 by 2. So again here we use the formula ddx of fx to the power n, fx to the power n minus 1 into derivative of m dash of x. So in this formula, fx replaced by 2x to the power 3 by 2 minus 3x to the power 4 by 3 minus 5. So by using this result, again we repeat the result, ddx of fx to the power n fx to the power n minus 1 into f dash of x. Similarly here 5 by 2, so right here 5 by 2. This bracket term as it is and to the power 5 by 2 minus 1. So we write this bracket term here. To the power 5 by 2 to the power 5 by 2 minus 1 into f dash of x means ddx of this bracket terms. So we write here ddx of, next we write here the dx of bracket term, and this is the bracket term here. So write this bracket here, because this bracket fx replaced by here this bracket. Therefore here dy by dx which is equals to 5 by 2 as it is, and this 5 by 2 minus 1, so here cross multiply 5 minus 2 upon 5 minus 2 upon 2, that is 3 by 2. So we write here, first we write this bracket here to the power 5 by 2 minus 1, after cross multiplications we get here 3 by 2 into, in this bracket we use here subtraction rule. We know that the subtraction rule, ddx of u minus v du by dx minus dv by dx. Similarly here This 2 as it is, 2 as it is, because here 2 constant. So here 2 as it is. ddx of x to the power 3 by 2. ddx of x to the power 3 by 2. So right here, this 2 as it is, ddx of x to the power 3 by 2. So write ddx of x to the power 3 by 2. X to the power, and here we write 3 by 2 minus, again minus 3. So 3 constant. ddx of x to the power 4 by 3. So write ddx of x to the power, x to the power 4 upon 3 minus ddx of 5, and 5 is constant, and we know that the derivative of the constant function is 0. Therefore, ddx of 5 here is 0. In the next step, therefore, dy by dx, which is equals to this 5 by 2 in bracket 2x to the power 3 by 2 minus 3x to the power 4 by 3 minus 5 to the power 3 by 2 as it is. So we write this here. This function is here as it is. In bracket, here 2 as it is. ddx of x to the power 3 by 2. Again, we use here the formula. ddx of x to the power n, x to the power n minus 1. So similarly here, n replaced by 3 by 2. So 3 by 2 into x to the power 3 by 2 minus 1. 3 by 2 minus 1. Cross multiply, so we get 1 by 2. So right here 1 by 2 minus this 3 as it is into ddx of x to the power 4 by 3. So we know that ddx of x to the power n x to the power n minus 1. Similarly, 4 by 3 as it is, 4 by 3 as it is into x to the power 4 by 3 minus 1. 4 by 3 minus 1. Cross multiply. 4 minus 3 by 3. 4 minus 3, 1 by 3. So we write here 1 by 3. The next step. This dy by dx is equals to 5 by 2. 2x to the power 3 by 2 minus 3x to the power 4 by 3 minus 5 to the power 3 by 2. Up to this step as it is. Up to this step as it is. Into this 2 to get cancelled. Therefore, 3x to the power half. 3 into x to the power half, or 3 into root x. X to the power half means root x. So right here 3 into here root x. So we write here root x minus this minus sign as it is. 3 get cancelled. So 4 x to the power 1 by 3 as it is. So right here x to the power 1 by 3. And this is the required derivative of the function here y is equals to 2x to the power 3 by 2 minus 3x to the power 4 by 3 minus 5 to the power 5 by 2. We find here the derivative of the next simple functions by using the formula ddx of fx to the power n fx to the power n minus 1 into f dash of x. to use this simple derivative formula and find out the derivative of these functions. So again, I request you, if you like my video, please subscribe my channel. Next problem, again we'll solve one problem. Problem number 3 in exercise 1.1 and unit is differentiation from mathematics part 2nd for class 12. So find dy by dx, find dy by dx if y is equals to under root, you write function and function is given x square plus 4x minus 7, x square plus 4x minus 7. And if I find the derivative of this function, that is here the given function is y is equals to under root x square plus 4x minus 7, and differentiate these functions with respect to x. So first we write here the given function. Given function is here y is equals to under root x square plus 4x minus 7. Differentiate both sides with respect to dx. Differentiate both sides with respect to x. Then we get here dy by dx, dy by dx, that is ddx of y, dy by dx, which is equals to ddx of RHS function, and here RHS function is under root x square plus 4x minus 7. Therefore, here dy by dx, that is equals to ddx of under root x square plus 4x minus 7. Again, here we use the simple derivative formula ddx of root fx, 1 by 2 root fx into f dash of x, 1 by 2 root fx into f dash of x. So we use this formula, and here we get 1 by 2 under root x square plus 4x minus 7 into ddx of x square plus 4x minus 7. So we write here 1 by 2, so write here 2 root x square plus 4x minus 7. So we write this here x square plus 4x minus 7 into ddx of in bracket here fx, here fx is replaced by x square plus 4x minus 7. So we write x square plus 4x minus here 7. Therefore here dy by dx, which is equals to this 1 upon 2 under root x square, this 1 upon 2 under root x square plus 4x minus 7 as it is. So we write this here, this is as it is, into, then we find here the derivative of this function, that is ddx of x square plus 4x minus 7. And here we use the addition and subtraction rule. So first we write here ddx of x square, ddx of x square, ddx of x square plus here 4 as it is, because 4 is constant, ddx of x, ddx of x, so right here x minus here ddx of 7, ddx of here 7. Therefore dy by dx, which is equals to this 1 upon 2 under root x square plus 4x minus 7 as it is. So we write this here, this is as it is, in bracket find here ddx of x square. By now that the formula ddx of x to the power n, x to the power n minus 1. Similarly here 2x to the power 2 minus 1, that is x to the power 1, that is x means 2x. So right here Derivative of x square is 2x. Then here plus 4 as it is. ddx of x, we know that ddx of x is 1. ddx of minus ddx of 7, 7 is constant and derivative is 0. Therefore, here the derivative of the required function is dy by dx, which is equals to here 2x plus 4 multiplied by 1. From this 2 take common. From this 2 take common. Then this 2 cancel. So x plus 2. If I take 2 common, then in bracket x plus 2. And this 2 and this 2 cancel. So x plus 2 upon under root x square plus 4x minus 7. So right here, from this bracket 2 take common, then 2 get cancelled, and in bracket x plus 2. So right here x plus 2 upon this under root x square plus 4x minus 7 as it is. So we write this here. And this is the required solutions of the third problem in exercise. And here exercise is 1.1. You name of unit differentiation from mathematics part second, and standard, that is 12 standard. So in this way, I solve here 3 problems from mathematics part second, unit name of unit, that is differentiation, and exercise 1.1. So again, I request you, if you like my video, please subscribe my channel and press on bell icon. Okay.